Good afternoon, everyone. This is group number 15, and we are going to talk about an application of symbolic learning in a couple of minutes. So, what is symbolic learning? Back in 1959, three AI pioneers set out to build a computer program that simulated how a human thinks to solve a problem. Alan Newell was a psychologist who was interested in simulating how humans think, and Herbert Simon was an economist who later won the Nobel Prize for showing that humans aren't all that good at thinking. They teamed up with Cliff Shaw, who was a programmer at the Rand Corporation, to build a program called the General Problem Solver. To keep things simple, Newell, Simon, and Shaw decided it was best to think about the content of a problem separately from the problem-solving technique, and that's a really important insight. For example, our brain would use the same basic reasoning strategies to plan the best route to home, USF, or wherever we need to go, no matter where we start. Computers are logical machines that use math to do calculations, so logic was an obvious choice for the general problem solver's problem-solving technique. Representing the problem itself was less straightforward, but Newell, Simon, and Shaw wanted to simulate humans, and human brains are really good at recognizing objects in the world around us. So in a computer program, they represented real-world objects as symbols. That's where the term symbolic AI comes from, and it's how certain AI systems make decisions, generate plans, and appear to think. If you've ever applied for a credit card, purchased auto insurance, or played a computer game, you've interacted with an AI system that uses symbolic AI. Modern neural networks train a model on lots of data and predict answers using best guesses and probabilities. However, symbolic AI, or good old-fashioned AI as it's sometimes called, is completely different. Symbolic AI requires no training, no massive amount of data, and no guesswork. It represents problems using symbols and uses logic to search for solutions. So all we have to do is represent the entire universe as symbols in a computer. To recap, logic is our problem-solving technique, and symbols are how we are going to represent a problem in a computer. Symbols can be anything in the universe: number, letters, words, people, concepts, actions, states, or things that don't physically exist. The collection of all true things about our universe is called a knowledge base, and we can use logic to carefully examine our knowledge bases in order to answer questions and discover new things with AI. This is basically how Siri works. Siri maintains a huge knowledge base of symbols, so when we ask her a question, she recognizes the nouns and the verbs, turns the nouns into symbols and verbs into relations, and then looks for them in the knowledge base. And now, let's see an application of symbolic learning in the real world.
Hello, I'm Jesse. I'm going to be talking about the applications of symbolic AI in recent years. And this is in regards to deep learning and symbolic AI being an extension of deep learning. So deep learning involves machine learning techniques which are based on numerical techniques. And so pretty much all the information that I will be presenting comes from these guys at Watson Lab, IBM, and MIT. They got a lot of good stuff, a lot of really current, very interesting videos. But to really talk about the applications of symbolic AI, I need to talk about neural nets. Now, deep learning, it basically is convolutional neural networks, also called CNNs, or I'll probably just call them neural nets. Modern neural nets are based on ideas of Frank Rosenblatt. This guy here, I called it this perceptron. Perceptron itself is just a mathematical formulation. Input on the left side of the screen, move right to the output. The right side of the neural net is basically just a more complicated version of the perceptron. So neural nets are nonlinear classifiers. They are supervised learning techniques, and they can be really accurate. The term superhuman is being used, which means better than a person can do by classifying. But neural nets have certain limitations because of their mathematical statistical nature. Symbolic learning is now being used by these guys Watson Labs to overcome some of these limitations. This is one example of neural net limitation. When we look at this picture, we notice that it's weird. We can tell it's a teacup covered in fur. When a neural net is presented with this image, it classifies it as a teddy bear. And this is actually a piece of art, French piece of art that I can't pronounce at the bottom there. So one impressive thing that neural nets are doing right now is generating captions for images correctly. As you can see here, man in black shirt is playing guitar. Construction worker in orange safety vest is working on road. Pretty accurate captions generated. Here are some where they were not so successful. The image on the right, for example, a group of people standing on top of a beach, is technically correct, but when we look at this image, we notice that that's not what's important in the image. There's something else big that's going on here. And these weird captions that are generated here actually represent a variety of problems with neural nets. Again, going back to the statistical nature. So the MIT group came up with Cleverer, which is an acronym, it's really long, which is a data set with tough questions for neural nets to answer. There are lots of people working on these questions. An example, Cleverer, here on the left, shows an image of objects. Now we read the question, are there an equal number of large things and metal spheres? Well, on the right, we can see that the answer is yes. We can work it out in our heads. Questions for neural nets to answer. And many people have been working. So we build a program that looks really complicated, and it is, but we're going to break it down into sections. So this first part is the neural net, which classifies objects in the scene based on features of the object, which you can see in the pink structured representation here. The bottom left green is the results are handed off to a language parser, which is a recurrent neural network, RNN. And then we get to the symbolic program, which is our portion. So our symbolic program is taking the results of the CNN, the structured representation, and the language parser, and using this to further identify objects. Now, neural nets have problems with these types of questions because of the way their features are represented. The table on the top here shows how a neural net represents features in a table. As you can see, if we look at one going across, there's green, cube, metal. These are the features of our cube that are in the picture. And now if we want to ask a question about how many cubes there are, we would have to add a number into this row 1. And in doing so, our concept of our color and our shape becomes entangled with this count of the cubes. And this is essentially where neural nets really struggle, is this entanglement of information. When we apply this problem to a symbolic AI model, you can see on the right side of the screen that these features really exist on their own. They are their own entities. They are not dependent on each other. This creates a way of disentangling features from the neural nets.
To sum up, some believe that symbolic AI is dead, but this assumption couldn't be further from the truth. In fact, rule-based AI systems are still very important in today's applications. Many leading scientists believe that symbolic reasoning will continue to remain a very important component of artificial intelligence. There are now several efforts to combine neural networks and symbolic AI. One such project is the Neurosymbolic Concept Learner, or NSCL, a hybrid AI system developed by the MIT IBM Watson AI Lab. NSCL uses both rule-based programs and neural networks to solve visual question answering problems. As opposed to pure neural network-based model, the hybrid AI can learn new tasks with less data, and unlike symbolic-only models, NSCL doesn't struggle to analyze the content of images. Maybe in the future we will invent AI technologies that can both reason and learn, but for the moment, symbolic AI is the leading method to deal with problems that require logical thinking and knowledge representation. These are resources we used making the presentation. Thank you for listening.